Question, let's go ahead and actually, when we get a problem like this, I like to sketch it out before doing anything. So we have this 5 kilogram box. We're going to push it to the right with 50 newtons. Somebody pulling to the left, so we'll call that FL. There's also somebody pushing down, so we'll call that downward force. And then we have a friction force going to the left. So let's go ahead and now draw the free body diagram. So we're going to have normal, we're going to have weight, we're going to have the downward force. We're going to have the pushing force, friction, and the force to the left. Now we can go ahead and set up our equations. And our goal is to get this coefficient of friction, which right now doesn't look like we can do it, so let's just take it a step at a time and see where we go. So we're going to get the pulling force is balanced by the left force and the friction. And we're going to have the normal force is balanced by the downward force and the weight. So now we can go ahead and try to put in some numbers. So the first thing, let's see. I know that the 50 Newton force is the pushing force. I know there's a force to the left of 10, and I know that F is unknown. So I end up getting the friction force is 40 newtons. That's going to be useful later for getting the coefficient of friction. Now let's see what we can do about this normal force. The normal force is unknown. I know the downward force is 10. And to get the gravity force, well, I know that weight is mg, and weight and force of gravity are the same, so 5 times 10. And so I'm going to get 50 newtons here. So I put in 50, and finally I'm getting that my normal force is a big fat 60 newton force. Now I can get the coefficient of friction using this guy and this guy. So friction is the coefficient of friction times the normal force, so 40 is mu times 60. And so I'm getting mu is actually equal to 2/3, or if you prefer, 0.67.